So let's see how we design it. So let's use the same formula which we used in the type 2. What was that? What is the total gain? Total gain before compensation. So let me call it total gain before compensation. KU 0, then omega naught over omega UGB square. This is the total gain, okay? All right here. LG0 uncompensated. So after compensation, what do we want? We want the total gain should be 1. So KU0 what extra component you will have?
Ki by S.
Ki? Why Ki? What is the midband gain? Kp. Not 1 plus. You are taking the effect of second 0 by having this component. Okay. So what you have to look here in this transfer function. In this transfer function, your midband gain is Kp, but what in the PID when we simplified it and separated out all the 3 components, then the proportional component of your PID has a 1 plus omega Z1 because of that 0 only, okay, but that 0 is already incorporated here in the gain, okay. So it should have only Kp. So this portion should not change. In the type 2 when we had and when we considered omega Z2, the only difference was that omega Z2 was coming from the output capacitor ESR, but this expression should remain same, it should not change. Okay. And what is Kp? In terms of 0. Okay. The reason I am not writing in terms of R1, R2 because what if you design it using GMC? So you have to generalize it, make everything in terms of omega Z1 and omega Z2. And then after that, if your omega Z1, whether it is a GM by C or a 1 over RC, you substitute that and from there find the values. So which means KU0 omega naught over omega UGB whole square Ki over omega Z1 So what is unknown term here? Ki. So we have to simply equate. So one of this will cancel out, okay. So you will get Ki equal to this will go that side omega UGB omega Z1 omega Z2 divided by KU0. Correct? Now if I have omega Z1, omega Z2 both at omega naught, then they will get cancelled out and your Ki will be nothing but omega UGB over KU0. And if you consider omega Z1 equal to omega naught by 2 and omega Z2 omega 2, then it will get half of omega UGB over KU0. Okay, so depending upon how you place omega Z1, omega Z2, you can find out Ki. So now let us take an example, and so we will take the same example which we had earlier, your LC values and your VDD, VM, everything same, and R1, R2 also same, which was 100K I think. Okay. So we need to calculate CI, RP, R1, CD. So let us see. So L equal to 3.3 microhenry, C equal to 10 microfarad, R1 equal to R2 100 kilo ohm, then VDD 1.8 volt, VM 1 volt. We do not care about beta. Okay, so but if it was GM, then we should have mentioned beta as well. So beta would be half in that case. So let us substitute here omega Z1, let us consider at omega naught by 2 and omega Z2 equal to omega naught. So your Ki will become, and what is omega UGB for 1 megahertz? 100 kilo radian, sorry 2 pi 100k radian per second. Okay. So let us substitute those values. Omega UGB is 2 pi into 100k radian per second. Then you have omega naught by 2 into omega naught divided by omega naught square, and this is nothing but 1.8 by 1 volt. Okay. So this will get cancelled out. What is the value of this? 6.28 into 10 power 5 over 1.8 into 2. So 6.28 divided by 3.6. 1.74 what into 10 power 5. Okay. And what will be the unit for this? Radian per second. Okay. And what is Ki? not RP.
RICI, 1 by RICI.
R1 CI. And R1 is 10 power 5 ohm. So CI is 1 over 1.74 10 power 5 into 1.74 into 10 power 5, which is 100 over 1.74 picofarad. How much is that?
50 picofarad. 57.4 picofarad.
57.4. Okay, which is same as what we calculated earlier, if you remember, because omega Z2 location we considered same. Now if you change omega Z1 or omega Z2, these values will change. So what else we need to calculate?
We need to calculate C.
No. What are the unknown components here? RP and CD. So CD can be calculated, R1 is known. R. Okay, so that is straightforward. How will you calculate RP?
1 by RPCI is the first zero.
Yeah, so from there
From there
you
I
can
find that.
So your omega Z1 is 1 over RP CI, and this is nothing but omega naught by 2, correct? So this is the one way. Let me use a simpler way. So what is Kp?
P equal to
Wait.
P by R. RP by R.
And Kp is Ki over omega Z1. Ki is 1.74 into 10 power 5 over, where is omega Z1? Omega naught by 2, omega naught was how much? Anybody remembers? I think 180 something, huh? Sorry?
174K.
Omega naught. Half of this, huh? So it will become half of this.
174K.
So it will become 2 actually. Okay. This implies Rp equal to 200 kilo ohm. Okay. So the reason I wrote Kp not, I mean you could have calculated simply by making omega Z1 equal to 1 over Rp Ci, but I wanted to see how much Kp we have. That's why I just wrote that. Otherwise it doesn't make any difference how you calculate. So we have to calculate CD. CD equal to 1 over omega Z2 into R1. Omega Z2 is, we are considering at omega naught into R1, 1.74 into 10 power 5 into 10 power 5, which is same as your CI. 57.4 picofarad. Okay. So now all the values are known. We will substitute this and plot. So let me just open. $200K, 57.4 pico, so it's quite possible that when you do your hand calculation and when you simulate, I mean your phase margin, what you are looking for, or your omega UGB, you may be slightly off, because those calculation most of the time are rounded off up to some decimal place. So don't worry about that. You may be 10%, 15% off, but it will be very close to that, and that's the whole purpose of doing hand calculation, that when you simulate in just one iteration you should be able to get the correct answer. So then after that you will know what needs to be changed in order to get the exact same value. So my UGB should be how much? 100K, and phase margin. So phase margin will depend on two factors. One is Z2 and Q. Okay. If Q is very high, then you know that by the time you hit omega UGB, the phase shift due to LC will be 180. So then in that case, tan inverse omega UGB or omega Z2 should be your phase margin. But if let us say that is not going 180 or close to 180, let us say it is going only 170, 175, then that much phase you have to add there. But in the worst case, it will be the phase due to the omega Z2 phase margin. You cannot get worse than that actually, because you know the maximum phase shift LC can give 180, not more than that. Okay. So this is your $110. So only 10 kilo hertz we are off, so which is fine. Let us look at the phase. Phase at phase. We are at 110K, 75 degrees you are getting phase, and it will keep going because we do not have any pole. Okay. So your phase will keep going, and where will it go? Maximum phase shift 90. Okay. Yeah, RESR will also come. So at very high frequency, if you look at, so that 0 will also cause. So at infinite frequency, you can see it will go to plus 180, and that is why it is rising actually. So which means if I want to look at this output, we already plotted that, if you remember. So it should be looking similar to that. So we can look at, see. So you have integrator, then you cancel out, then second 0, and it will keep rising, and your phase. Let me look at phase. Okay. So I am plotting from 1K, that is why it is not showing that. And since it is inverting, so you have to include that 180 whenever you look at the plot. This is what we had, okay. And since this is Bode approximation, that's why, but you will have some non-linearity in the actual curve. So, those knees will be rounded off and your phase is